microstrip patch antenna design by using Inset feeding method, and we will see for gsm900 MHz operating frequency, resonance frequency of application. And after designing this patch antenna, we will see how this insect feeding method help the matching of this antenna. After designing the patch antenna, we will see how we can improve the parameters of an antenna like bandwidth, matching, VSWR, and operating resonance frequency plot. And after that we will see how we can shift the resonance frequency to another resonance frequency. Similarly, we will see other parameters that affect the result of the antenna, like by changing the substrate height or changing the substrate material, what will affect on antenna, and similarly by changing the length and width of this patch, what effect will occur. And we will also discuss the basic principle of these changes. Now let's design patch antenna for gsm900. As I explained, we will discuss the properties of antenna, so I am going to give the parameters to the values of substrate, patch and ground, so that we can add the parameter sweep in the result of this antenna. So by this way we can quickly discuss the properties of this antenna. Here you can see that for substrate, for patch, these parameter we will going to use. The first is ground plane by using the rectangle. Now I am going to add the parameters in the dimension of this ground. Here I use the position parameter, and z-axis is 0. This is substrate of y dimension. Press OK. Similarly, add parameter in x and y dimension as a substrate of x, substrate of y. Here I have explained the parameter description. Press OK and put all in active view. This is our ground plane. Assign this ground plane boundary as a perfect E. The second one is substrate. I am going to design a substrate on a top of ground plane. Now I am going to add in the dimension of this substrate. Here you can see that similarly as a ground, the starting position. Now the x-axis will be substrate of x. In this way, add the parameters in x, y dimension. It's okay. The height of this substrate is 1.6 millimeter. That's okay. And I'm going to press it. Next is patch design on the top of substrate. Now add parameter for patch of this antenna. This is we have. Similarly, add parameter in x distance and y distance. Press OK. This is we have patch. Next is inset feed. Next is the dimension of inset feed line. Here you can see that FW and ID, we can check it. FW we have is feed width and ID is inset feed distance. Now adding the values of feed width. This is the dimension of feed width, 4.852 millimeter. Press OK. Next is inset feed distance, which is 34.117 millimeter. Press OK. Now I am going to add the parameter in x and y length. X dimension is feed width. The y dimension is feed length, FL. Here you can check this. This is feed length. I am going to add value, which is 101.533 millimeter. Press OK, and after this I will press OK. Now you can see that this is a feed. And we will discuss why this feed not reaches the end point of this substrate, or if we are designing in the mid position, what changes will occur. We will discuss this. Now we will create an inset feed gap here on the sides of this is inset feed line. Now I have added the parameter origin position of this gap. You can add this equation. Here is IG is, we have IG is inset feed gap whose dimension is 2.426 millimeter. Add this dimension for x-axis feed width, add with 2 times multiple of inset feed gap. This is FL feed length. Press OK. Now you can see that this is a rectangle. We can name it as a gap. Okay. Feed line. Now I am going to create a lump port here. For that purpose, first change axis into ZX. We can design port directly, but I am going with a complex method by adding parameter to the position of every geometry and parameter in the dimension. The main purpose is we will use this parameter to add the parametric result in sweep, and similarly we will discuss the all parts of this antenna properties by changing ground, substrate, patch, length, width and material property. What changes will occur in result, we will discuss that. For that purpose we are going to a complex process. Now this is the position of feed. This is feed position. Now add these all parameters into it. The purpose of parameterizing the port is when we will increase the length and width of inset feed line, obviously the position of this port will also change with respect to changing the dimension of patch or feed line. So when we add the parameters to a position and length and width of this port, this port position will automatically change according to the parameter dimensions. The main purpose is this. Add this and press OK. Now this is our port. If you are missed any parameter value, you can check it from your design properties. These are the all parameters that I have added in this design. If you want to compare the values of all parameters, you can compare it, and similarly you can edit it if there is any mistake you have made. In this way you can edit it. By changing the value, press OK. The values in a design will get changed. Also we will check incoming design. Now I am doing the operations on this. First is subtract gap from page. First press on page, then on gap. Here is subtract. Press OK. Now you can see that this happened. This will happen. And after that, add the feed line with page. Here is unite. Now you can see that this is page. Similarly, assign material to page as a perfect T, boundary as a perfect T. Now here is unassigned is port. I am going to add lump port. For that purpose, I am going to rotate this design. For assigning port, just click on port, and here is fit selected diagram in active view, and add excitation as a lump port. In this case, the resistance of this lump port is by default 50 ohm. From here you can check the port has been assigned. OK. Similarly, the boundaries, this is ground plane, which is perfect T. This is page, which is perfect T. Now I am going to add material in a substrate. Now I am working on a substrate with dielectric value is 2.2, effective dielectric. Now that is because we have relative permittivities 2.2. Changing the name into MIMO. Similarly, the value of permeability is 1, and dielectric loss tangent value is 0.309. And here is mass density, which is 0. After adding this, we will put this into active design and also in this product. Press OK. Now search from here my material. This is our new assigned material with respective properties. I will press OK. The material has been assigned to substrate. final remaining is radiation box, the portion in which we will study the radiation behavior of this antenna. I am going to parameterize this radiation box. The purpose is when we will change the dimension of antenna, that this radiation box value we have to increase or decrease accordingly. For that purpose, and we will see by changing the dimension of radiation box any effect on result in coming tutorials. Lx we have 700 millimeter is Ly length along y-axis is also 700 millimeter. The height of this box will be 300 millimeter. Now I am going to change the dimension here into Lx. Ly and height as a h. Press OK. This is our radiation box and here is substrate. By rotating this we can check that our design is completely inside this radiation box, and assign material to this radiation box as radiation. Now after that, check the validation. The analysis setup it does not added up to yet. I am going to add frequency sweep. In this case we are operating from gsm900 for 0.9 GHz for 900 MHz. Change number of passes to 15. Press OK. Now I am going to add sweep, frequency sweep. Add this start frequency and stop frequency and step size. For sweep of result, press OK. Sweep has been added here. You can check it is completely OK. Now I am going to analyze this project, and next part we will discuss the result and we will add sweep in this different parameters, in the parameters of pitch, antenna dimension, in feed line, and by changing the gap dimension we will see the result effect or not effect, and how we can shift the band, how we can improve the band, and how we can change the substrate material, and how we can change the materials dimension, substrate dimension. Similarly, I will also discuss how by using equations we can find the values of length and width and dimensions of all design for a specific operating resonance frequency for gsm900 2.4 or any frequency in microwave range.